Hello everyone, welcome back to my channel. This is the 8th video of our Data Science Basic to Advanced course. Today we are going to learn about clustering. So, clustering is one of the most important techniques in unsupervised learning. So, clustering is one of the most important techniques in unsupervised learning where the goal is to organize data into groups or clusters that exhibit similar characteristics. It helps reveal patterns and structures in datasets without any prior knowledge of labels or categories. Essentially, clustering algorithms try to partition data based on inherent similarities or distance between data points. Now, what are the key objectives of clustering? The first one is groups similar data points. The primary aim of clustering is to identify data points that are similar and group them together. Similarity is typically defined by some mathematical distance or similarity measure. Find hidden patterns. It helps identify underlying structure, trends, or patterns within a dataset which may not be immediately obvious. Data summarization. Clustering can be used to reduce the complexity of the dataset by summarizing the data into a smaller number of groups or clusters. Outlier detection. Clustering also helps in identifying outliers, data points that don't belong to any group, which can be useful for anomaly detection. Now, the popular clustering algorithms are: first is the k-mean clustering. It works as the user specify the number of clusters k, the algorithm randomly initializes k centroids and assigns each data point to the closest centroid. The centroids are recalculated based on the mean of the assigned points, and the process repeats until the centroids no longer change. Now, the second type of clustering is hierarchical clustering. In this clustering, bottom up starts with each data point as its own cluster and progressively merges the closest clusters. Divisive, top down, starts with all the points in one cluster and recursively split them. Let us understand by running the code of Python how clustering works. Here we have a simple code of Python which explains us k-mean clustering. In this code, we are importing necessary libraries and loading and preparing the data. We will use the IS dataset for demonstration purposes. Now in step 2, we are standardizing the data, and in step 3, we are applying the k-mean clustering. Then we are getting the result, and then we are visualizing the result. We will use only the first two features, spell length and spell width. Now we are plotting the centroids of each clusters. After that, we have to label and title, and after that we have to show the plot and print out the cluster centers and labels. Let us run this code, and now let us see the result of our code. Here, the scatter plot of the dataset where each point is colored based on cluster it belongs to. Also, the centroids of the clusters are displayed as red crosses. Here, these crosses are representing the centroids of the clusters, and the program prints the centroids and the cluster label for each data points. So, it is the output that we are getting from our code. Now, let us understand some of the applications of clustering. So the application of clustering involves customer segmentation, image segmentation, anomaly detection, document clustering, and biology. In customer segmentation, businesses use clustering to group customers based on purchasing behavior. In image segmentation, in computer vision, the clustering is used to segment an image into distinct regions based on pixel similarity. In anomaly detection, outliers or anomalies in the dataset are detected. Document clustering in nature and natural language processing (NPL) Clustering is used to group similar documents together, enabling topic modeling, recommendation systems, or organizing large data sets. Clustering in biology is used in genomics to group genes or organisms that exhibit similar characteristics, often based on genes expression data. This was all for this video. Thank you for watching.